Confidence interval for estimating a population standard deviation or variance. Objective: construct a confidence interval estimate of a population standard deviation or variance. Notation: sigma represents the population standard deviation. Sigma squared is the population variance. Lowercase s is the sample standard deviation. Lowercase s squared is the sample variance. Lowercase n is the number of sample values. Capital E is the margin of error for chi-square. Chi-square with a subscript of L is the left-tailed critical value of chi-square. And chi-square with a subscript R is the right-tailed critical value of chi-square. What are the requirements? That the sample is a simple random sample. Number 2, the population must have normally distributed values. The requirement of a normal distribution is much stricter here than in earlier sections, so large departures from normal distributions can result in large errors. The confidence interval estimate for the population variance. So the formula is the following. The population variance is in the middle here. On the left, it's n minus 1 times the sample variance divided by the chi-square critical value on the right. And then the value on the right-hand side is parentheses n minus 1 times the sample variance divided by the chi-square critical value on the left. Now, the confidence interval estimate for the population standard deviation, what we'd have to do is take each of those on the left and right side of the population variance and take the square root of those values. The round-off rule. The original data. When using the original set of data values, round the confidence interval limits to one more decimal place than is used for the original data. Number 2, summary statistics. When using the summary statistics, round the confidence interval limits to the same number of decimal places used for the sample standard deviation. Procedure for constructing a confidence interval for the the population standard deviation or the population variance. Number 1, verify that the two requirements are satisfied. Number 2, using n-1 degrees of freedom, the critical values chi-square on the right and chi-square on the left that correspond to the desired confidence level. Number 3, to get a confidence interval estimate of the variance or the population variance, use the following. Here's our formulas on the left and on the right, and this would represent for the population variance. And then to get a confidence interval estimate of the population standard deviation, we would take the square root of each component of the above confidence interval. And then number 5, we would round the confidence interval limits using the round-off rule. Now, using confidence intervals for comparisons or hypothesis tests. Comparisons. Confidence intervals can be used informally to compare the variation in different data sets, but the overlapping of confidence intervals should not be used for making formal and final conclusions about equality of variance or standard deviations.